Hello friends, welcome to our channel Piping Mantra. Today we are going to learn about pipe supports. It is a very important topic which is used while preparing piping layout and ensuring the required flexibility in the pipe. So without wasting any time with the intro, let's quickly get to the video. The piping profile in general can be considered as a complex and rigid piping network consisting of various piping components which can have different diameters and weights. At the same time, this piping network is also subjected to temperature change while switching from installed to operating conditions and vice versa, resulting into thermal growth in various directions in proportion to the length of pipes. A satisfactory design of the piping system should therefore give a careful consideration to achieve these requirements. This is generally accomplished by providing external attachments known as pipe supports at various locations of the piping profile. In this video, we are going to see the basic purpose of the pipe supports, classification based on construction or functions, and a few typical types of pipe supports along with general consideration of pipe support for different piping systems. At first, we will identify the purpose of pipe supports. Its main purpose is to support the weight of pipe during operation and testing. Next is to take expansion load. Whenever thermal expansion is restricted by support, it introduces additional load on the support. Support must be designed to take this load in addition to all other loads. Next is to take wind load. Wind introduces lateral load on the line. This load is considerable, especially on large diameter pipes. This tends to sway the line from its normal position, and line must be supported and guided against it. In case of large diameter overhead lines supported by tall support extended from floor, wind load introduces large bending moment and should be considered critically. Now comes to take earthquake load. The earthquake is normally associated with horizontal acceleration of the order of 1 to 3 meter per second square. This is around 10 to 30% of the gravitational acceleration and introduces horizontal force of about 10 to 30% of the vertical load or supported mass. Next is to absorb vibration of piping systems. When the pipe is subjected to moving machinery or pulsating flow or very high velocity flow, pipe may start vibrating vigorously and ultimately may fail, particularly if span is large. Next purpose is to have noise control. In most of the plants, noise is resulting from vibration, and if such vibrations are controlled, noise is automatically reduced to a great extent. In such lines between clamp, that is support, and pipe, asbestos cloth is put to absorb vibration and avoid noise. Noise due to pulsating flow can be reduced by using a silencer in the line. Next in line is to take hydraulic thrust in piping. The hydraulic thrust in the pipeline is present at certain points such as pressure reducing valve, relief valve, bellows, etc. If the control valve has large pressure differential and line size is more, then this force can be very high. Next purpose is to support the system during transient period of plant and standby condition. Transient condition refers to the startup or shutdown condition in which one equipment may get heated up faster and other one gets heated slower. Next is to support the system during maintenance conditions. When for maintenance of certain equipment or component like valve is taken out, remaining system should not be left out unsupported. Referring to the figure, support S1 will be sufficient, but when valve V1 is taken out for maintenance, there will not be any support for vertical leg. Therefore, second support S2 may be required to take care of such conditions. Next is to support the system for erection conditions. Now comes classification of pipe supports. Broadly, the pipe supports are classified in three groups as per following details or functions: general details, construction details, and functions or purpose. First, we will discuss about classification as per general details. A pipeline needs to be supported from a foundation or a structure. The piping loads will be acting on these foundations or structures. Since these are built on ground, they will exert an equal and opposite reaction while supporting the pipe. In a pipe support, there will be some part of support arrangement which is directly attached to the pipeline, and there will be some other parts which shall be directly attached to the foundation or structure supporting the pipe. As per this general detail, the support is classified as primary support and secondary supports. Now, Let's have a look at classification as per construction. Based on construction details, pipe supports are broadly classified in three types, as rigid supports, elastic supports, and adjustable supports. First is rigid supports. This type of support arrangement is generally very simple and has maximum use in piping. It does not have adjustability to the erection tolerances. It will directly rest on foundation or structure which is supporting the pipe. Common type of rigid supports are welded shoe, clamped shoe, trunnions, valve holders, support brackets like secondary supports. Next is elastic support. This type of support is commonly used for supporting hot pipes. It shall be able to support pipes even when the pipe is moving up or down at support point. Common type of elastic supports are variable type spring supports, constant type spring supports, etc. Last one is adjustable supports. This type of support is rigid type in construction, but it has a few nuts and bolts arrangements for adjusting the supports with respect to the actual erected condition of pipe. The support can be adjusted for the erection tolerances in the pipe. These are required for a better supporting need at critical locations of pipe supports. Now comes classification as per function, that is purpose. Pipe supports classified as per functions are shown along with its basic construction, the symbol generally used, and the type of restraint it offers to the piping system. As you can see on your screens, this table gives you a more clear picture of the direction in which they provide the restriction and the direction in which they can allow the movement, with their names and symbols respectively. Let's discuss each of these components one by one. First is rest or loose support. This is most commonly used support meant for supporting only the pipe weight vertically. It allows pipe to move in axial as well as transverse direction but restricts only the vertical downward movement. It comes with or without shoe. Next is longitudinal guide. This type of support is used to restrict movement of pipe in transverse direction, that is, perpendicular to the length of pipe but allow movement in longitudinal direction. This is also a commonly used type of support. Generally, it is used along with the loose support. Next is transverse guide. This type of support is used to restrict the movement of pipe in longitudinal or axial direction but allows the pipe to move in transverse direction. This is also referred as axial stop. This type is less used as compared to above two types. Generally, it is used along with loose support. Now comes non-welded type, four-way guide. This can be considered as a combination of longitudinal and transverse guide. This type resists only the linear movements in all directions but not the rotational movements. This avoids heavy loading of support as well as pipe. Therefore, this type of support is preferred over welded type. Next is welded type, anchor. This type of support prevents total movements, that is linear as well as rotational. This type of support is used when it is absolutely essential to prevent any movement or force being transferred further. It causes heavy loading on support as well as pipe. The next in line is limit stop. As name itself indicates, it allows pipe movement freely up to a certain limit and restricts any further movement. This is useful when total stops causes excessive loading on piping and support or nozzle. This type of support should be used selectively because of stringent and complicated requirements of design, erection, and operation. Last one is special supports. When we need a pipe support whose construction or functional details are different from the available details, then special support detail sketch is prepared. The function of this support can be any combination of above functions. Following are the types of supports generally used in a project. First is shoe type support. Shoe type supports are the maximum used supports in any project. These can be directly welded to a pipe or can be welded to a clamp and put around the pipe. Shoe type supports are used for supporting lines with insulations. Basically, it is used as a rest support. With slight addition of details, it can also be used as a guide, fixed point, anchor, transverse guide, limit stops, etc. It can be modified to be used as adjustable supports also. These are primary supports and will be supported on secondary supports if required. Now shoe height vary as insulation thickness varies. For example, shoe height will be 100 mm for insulation thickness of less than or equal to 75 mm. Shoe height will be 125 mm for insulation thickness from 76 mm to 100 mm.
For a slope line, shoe can be tapered as per the desired height to match the elevation of pipe.
Next is trunnion supports. In this type of supports, a dummy pipe is welded to a main line so that the dummy pipe becomes a rigid part of the main pipeline. Now, this pipe is suitably supported on a secondary support, foundation or a structure as you can see in the picture. As per piping requirement, the trunnions can be vertical as shown or horizontal. These can be used for rest supports, guides, transverse guides, fixed points, anchors as well as adjustable supports. On your screens, you can see different symbols for trunnion supports for horizontal, vertical and double trunnions. Now comes hanger support. As the name suggests, in a hanger support, the pipe is hung from a structure using a hanger rod. It is clear from the figure that pipe can move in all directions except downwards. A hanger support generally uses a clamp on the pipe. When a turnbuckle is used, then the support is adjustable type. Hanger rods are used as a rest supports which are free to lift up. Next is valve holders. Valve holder is a special type of support which is used in the situations where it is intended to directly support the valve body through its flanges. It is an assembly of two holder plates bolted to the end flanges of the valve to be supported. These holder plates are in turn bolt connected to a common base plate to complete the valve holder assembly. This support is relatively expensive since it involves many fabrication steps, for example machining, drilling of holder plates, etc. This support is therefore used only in the situation where it is absolutely necessary to directly support the valve body owing the weak pipe material, for example plastic piping, which is incapable of transferring the valve load, the support through the pipe section. The above support is therefore not called for in case of carbon steel piping. This support is generally used for rest support, guide support and fixed point. Next is spring support. Spring support is a special type of support which is used in the situations where the support point on the pipe is expected to move up or down during the operating conditions due to thermal growth. From its installed position without spring, the pipe will therefore either lift from secondary support or will make an unsuccessful attempt to press against the rigid secondary support. Both are detrimental to the structural integrity of the piping system. The spring support basically employs a spring element which can get compressed or open up depending upon the thermal movement at the support point of pipe. By doing so, it takes the vertical load of the piping under both the situations. From the utility point, spring supports are classified as variable spring type and constant spring type. As per arrangement, spring support can be classified as supporting the pipe from under, that is resting type, or as supporting the pipe from above, that is hanger type. Now let's discuss about variable and constant spring supports. First is variable spring support. This basically consists of spring which can get compressed or expanded according to thermal expansion. However, this movement causes increase or decrease in supporting force depending on its stiffness, and this differential load is transferred to the pipe, but this is much less than that would be with rigid support or rigid hanger. Variable spring supports are further classified as hanger type or bottom support type. Next comes constant spring supports. In variable spring support, variability factor is generally maintained within 25%. When the vertical movement of support point is large and or a very less magnitude of differential force from cold to hot condition is permissible, then constant type of support is used. This is also basically spring support, but load is supported by it through a lever mechanism in such a way that when spring gets compressed, effective leverage is reduced and vice versa, so that net supporting force remains constant, that is without any load fluctuation. Like variable spring supports, these are also available as hanger type and bottom support types. Now let's discuss about these two terms, hanger type and bottom support type. First is hanger type variable. In hanger type variable spring supports, the pipe is hung from the secondary support using hanger type spring as shown in the figure. Next one is bottom support type variable. In bottom support type variable spring, the pipe is resting on top of the spring load plate as shown. The selection is based on the availability of structure. These are better described or shown in manufacturer's catalog, Sarthi, Anvil, and UMA, whose catalog for all of the above are available. From all the above description, it may create the impression that constant spring supports are better than the variable spring supports. However, it is not so. The reasons are constant support is costlier than the variable spring supports, and they cannot adjust itself to actual variation in loads. Now comes adjustable supports. As the name suggests, this type of support is capable of adjustment at site to accommodate erection tolerances of piping. Basically, all types of supports can be easily modified and made adjustable. A typical example of for support at pump suction is shown on your screens right now. These type of supports are generally used as rest supports. Now comes U-bolt type support. U-bolt type support is one of the simplest and extensively used primary support item for supporting uninsulated piping. These are generally used as guides and anchors. These can be used conveniently as fixed points for smaller size, non-insulated piping. All support discussed before this has been primary supports. So let's talk about some secondary ones. First is support brackets. The support brackets are structural frames used in between the primary supports and the building structure. The support brackets are fixed to the building structure or foundations. These are required at places where the pipe cannot be directly supported from a building structure or any foundation. The members used for brackets are structural items like beams, channels, angles, plates, etc. On your screens, you can see different arrangements of secondary supports. Last topic of this video is pipe supports and its general consideration for different piping systems. The construction features of various types of pipe support described in the earlier sections vary depending on the type of piping system where the support is intended to be used. First is un- or non-insulated piping of carbon steel and stainless steel. Second is hot insulated piping of carbon steel, stainless steel, and alloy steel. Third is cold insulated piping, and last is plastic piping. Let's discuss these one by one. First is uninsulated CS piping. The uninsulated carbon steel piping, that is bare pipe, generally rests directly on the secondary support for up to 12 inches of sizes. For big diameter pipes with NB greater than 14 inches, a pad is needed to avoid ovality formation in pipe at support. Generally, U-bolts can be used at guides. Guide lugs can also be used. For fixed point at non-critical locations, beams needs to be welded at bottom of pipe. Next is uninsulated SS piping. The uninsulated stainless steel pipe do not rest directly on the secondary supports. Either pad or shoe type support with clamp of carbon steel is used for support. A thin stainless steel sheet or an asbestos cloth is used between pipe and clamp. Next is hot insulated CS piping. The hot insulated CS piping never rests directly on secondary support. Shoe type support of carbon steel with or without clamp is used. As you can see on your screens, the examples of shoe guide support and anchor support. Trunnion type supports can be used if not objected by client or some licenses. U-bolts are not used. Next is hot insulated SS piping. The hot insulated stainless steel piping, that is less than 350 degrees Celsius, will generally use shoe type supports of carbon steel with clamp. A thin stainless steel sheet or an asbestos cloth is used between pipe and clamp. When welded type shoe is required, then the pipe shall have an SS pad welded to a pipe. The CS shoe shall be welded to SS pad. When trunnion is used, a short length of trunnion will be of SS or SS pad will be used. Next is hot insulated AS piping. The hot insulated alloy steel piping shall generally use shoe with clamp. Whenever essential, welding type shoe can be used. Trunnion type supports can be used if accepted by client or licensor. The material of clamp and shoe shall be carbon steel or alloy steel depending on the pipe temperature. Next is cold insulated piping. Cold insulated piping generally uses pipe shoe with clamps of carbon steel. The clamps are put over the cold insulation blocks. Pipe shoes with clamp put directly on the cold pipe will need special insulating blocks of high density nitrate block between pipe shoe base plate and the secondary support member. In this case, the support material needs to be compatible with the pipe temperature. Trunnion type supports are generally avoided. Last one is plastic piping. Plastic, being a weak and soft material as compared to metallic piping, is vulnerable to local stressing and notching. Therefore, the pipe supports used for plastic piping necessarily employ a clamp shoe assembly of carbon steel with a soft PVC sheet in between pipe and clamp. So, that is it guys for today's video. We will come back soon with another interesting topic. So, till then, stay tuned and keep on watching. If you have any queries or doubts, please write to us in comment section below. Also, please like, share and subscribe and send us some love. Please click on that bell icon so that you can get notified every time we upload new content. Till next time, bye bye, take care.